Aloha and welcome to the Properties of Minerals video. In here we'll go over a couple of the properties that we use to identify minerals. So we'll take a look at color, streak, luster, crystal form, hardness, cleavage, fracture, density, and a couple other properties as well. Okay, so the first property we want to talk about is color. And color is simply what color is the mineral that we're trying to identify. Color is probably the worst trait to look at because you can have a little bit of impurities and those impurities will change the color of the mineral. So we generally try not to use color. It's a good starting point, but it's not something that's going to be really good to use. The type of color that is good is if we use something called streak, and streak is going to be the color of its powdered form. So if we look down in here, this picture, you can see that hematite has kind of a reddish brown streak and magnetite is going to be kind of a grayish streak. And we get the streak by taking our mineral substance and just kind of basically rubbing it on this unfired piece of porcelain, which we call a streak plate. So remember, the color of the powdered form is going to be better than just the color of it. Now, we also have another term called luster, and luster is simply how light's reflected from the surface. So we can kind of see some examples here. We have metallic here, we'll have a silky kind of reflection here. You'll have a dull one, kind of looks greasy, so kind of just how it basically the light is reflected from the surface of it. So that gets us our color, our streak, and our luster. Another good property to use is crystal form, or which family is it in. This is really a good one because remember, as a mineral it has to have an ordered crystalline structure, and this is what forms the crystal form for it. So we can kind of see there where it's important. The problem is that for you to get the perfect crystal growing, you have to have something that is unlimited in space and unlimited in supply. So if there's other rocks around and you're growing a crystal in a small area, it's going to bump into the rocks and that's going to change its shape because it's kind of compressed and it's kind of isolated in there. So if we can grow one that has it, then we can use its crystal shape to help us out. One of the better properties to use is what we call hardness. And hardness we rate on the Mohs hardness scale, which you can see here. It goes from 1 to 10, and quite simply the numbers tell us kind of how easily it is to be scratched is what we talk about. So we start down here with talc and gypsum. Those are going to be really easy to scratch. They're kind of easy, delicate minerals, all the way up to diamond, which is the hardest natural substance that we know. And that one's very difficult to scratch. In fact, it's really easy to scratch other things with it. And that's how you test for hardness, is you'll take like a piece of gypsum and scratch a piece of talc, a piece of calcite will scratch a piece of gypsum, a piece of topaz will scratch a piece of quartz, and so on. Now there are some common objects that we use in the testing just so that we can kind of see what the difference is. So your fingernail's at about 2.5, a copper penny's at about 3.5. So you could take your fingernail and scratch gypsum and talc, but you would not be able to scratch calcite because it has a 3. We have a knife. We have our steel nails and like a masonry drill bit. So you can see just by testing to see which one it scratches or scratched by it, that's how we can determine hardness. And this is a really good indicator of what mineral it is. Now the next two terms we're going to go over are cleavage and fracture. And these deal with how a mineral breaks. When we have cleavage, what we say is that it's going to break in one direction and form a flat surface. So if we look at muscovite here, you can see it breaks off in these little sheets, and you can see that it's a flat surface. We can have it in 2 directions like feldspar, 3 directions like halite, 3 other directions in calcite, but you see that all of these are going to have these flat surfaces to them. And that tells us that it's cleavage, if it's a nice even flat surface. If it doesn't break that way, then we define it as having fracture. And you can see in the rocks shown down here that they're all just kind of mumbly-jumbly and broken apart. There's no real flat surfaces. I mean, you can find tiny ones, but overall there's no big flat surfaces like you'd see here. All right, so cleavage is if it breaks on a nice flat surface. Fracture is if it's an uneven breaking. Now, density is a really good way to identify the mineral. Density quite simply tells us how much stuff I have in a certain amount of space. And you can see that this one here is going to have more stuff in the same amount of space, so it would be more dense. We calculate density by finding its mass on a balance scale and then finding its volume. We take the mass divided by the volume, and that's what gives us our density ratio. So density is really good. It helps us out in identifying which mineral because they all have a varying different density, and we can find simple little subtle differences in density a little easier than say hardness or luster. And then we have some other properties that are out there. Some of them, by the way they touch, they feel. Some may feel greasy, some may feel slimy. Malleability, they're easily shaped. If you take gold, you can change the shape of it, so it's malleable. Metals, you can do this. Some of the other ones, if you smashed a diamond with a hammer, then it would just shatter, whereas if you smash gold with a hammer, it'll flatten out. We have magnetite and hematite, which are going to be magnetic. Hematite is magnetic. You can pick it up with a magnet. Your magnetite is going to be actually a magnet, so you can actually pick up small paper clips and things that way. Some of them will have a distinct smell. Sulfur is a really good example of this one, where when you scratch it with your fingernail, it smells like rotten eggs. Some of them like taste, your halite, okay, which is your salt. You'd be able to taste that, but I don't recommend going out and licking rocks. And then we have some optical properties. If we look at calcite over here, calcite exhibits double refraction. So you can see that if we take a piece of calcite and put it down on words, we're getting two images formed, and that's what that double refraction is. Okay, so that was a quick overview of the properties that we look at in minerals to identify them. The lesson will go through these in detail, and then we also have a lab coming up where you'll get to practice identifying which minerals are which. All right, as always, good luck in your lessons, and we'll see you in the next video.